Hi ladies and gentlemen, this is Mr. Green. This is a review for Algebra 2 for Unit 6 for second semester. So I want to make certain I go through this. I'm going to try to get through this without making too many errors, okay? First of all, this says complete the problems to prepare for the unit test. Answers to be provided at the end of the student guide. So I'm basically just working the problems that are in the student guide, okay? So this one is asking, first of all, uh, find the dimensions of each matrix and tell if it's a matrix or a vector. Well, I see two rows and two columns in this one, so it's going to be a 2 by 2 matrix. I see 4 rows and 1 column in this one. This one is a vector. This one I see 5 columns, 2 rows and 5 columns. It's a 2 by 5 matrix. Okay? If you're ever confused about this, you can always just bring up the calculator and go into matrix. And when you go over here to edit, hit enter, it'll ask you some information. So if you said a 4 by 1 matrix, see how it puts 4 columns here, 4 rows here, and just 1 column? So that's going to be pretty much what we're looking at there. That's how you can tell them apart. Calculator can help you there, even though you're not putting in a full matrix. Okay? This one's asking, what's the element with the given value? So we're looking for 38. It's right here. You do columns first. So it's in position 3, 2. 9, well, it's right here. It's in position 2, 1. And then 19, that's right down here. So that's in position 1, 3. So you can see these things are just pretty straightforward questions. Nothing difficult going to be on this test. Okay? So if you're looking for Z21, so that's going to be over 2 down 1, 196. What does that represent? It represents the 10 to 12. Let's see here. Let's see here. These are the matrix showing the number of people in each age group that has entered the zoo at different 2-hour time periods during the from 8 to 4 o'clock. So this represents the kids that were 13 to 34 that entered between 10 a.m. and 12 p.m. Okay? So what is Z43? It's this 33 number here. This is the kids that, or the people that are 35 to 64 that entered from 2 p.m. to 4 p.m. And how many people entered the zoo between 2 and 4 p.m.? All you have to do is total up this column right here. So that'd be 9, 10, 11, 12, and 6 would be 18. Carry your 1, 10, 15, 16, 17, 18, 19, 198. So 198 people entered between 2 and 4 p.m. Okay? So this one, we've got A, we got B, we got C. These are all 3 matrices. If I wanted to find A plus C, that's going to be 2 plus -5, that's -3. -18 plus -10, that's -28. 15 plus 15, that's 30. 10 plus 0, that's 10. We just added it together. No problem whatsoever. If I wanted to take B minus 3A, I'm going to be multiplying these by 3. So it's going to be 7 minus 2 times 3, which is 6. 7 minus 6 is 13, -13. 21 minus 3 times 18. Well, I can't do my 18s all that closely. So 18 times 3 is 54. So it's going to be 21 minus 54. No, 21 minus a -54. That's going to be 75. Positive 75. Okay? And if I take 34 minus 45, 34 minus 45 is going to give me 11. -11. And -6 minus 30, that's going to be a -36. You can see how I'm doing those. I'm doing them quick, but they're not that hard to do. Now, this last one, A times C, I'm going to take 2 times negative 5. That's negative 10. And 18, negative 18 times 15. I can't do that one in my head. Negative 18 times 15 is a negative 270. So minus 270. Okay. That's going to be the first entry. I'm going to take the 2 and the 18 times 10 and 0. 2 times negative 10 is going to give me a negative 20. And negative 18 times 0 is going to give me 0. 15 and 10. 15 times negative 5 gives me negative 75. And then 10 times 15 is 150. Negative 15 times negative 10 is a negative 150 plus 0. And those would be the entries I'll have there. So this will be negative 280. This will be negative 20. This one will be 175. And this will be negative 150. You guys see how I did that? I took this row times this column, and that was the first entry here. That's how you multiply matrices. Going on here. If I'm going to find PQ, and this is going to be a big matrix multiplication, I want to show you how I'm going to do it. 2 times 4 gives me 8 plus. Negative 3 times 2 gives me negative 6. 4 times 6 gives me 24. 2 times 5 gives me 10. Next row over. 2 times 2 gives me 4. 3 times 0 gives me 0. 4 times negative 2 gives me negative 8. 2 times 1 gives me 2. Next row over. 2 times 1 gives me 2. Negative 3 times negative 3 gives me a positive 9. 4 times negative 2 gives me a negative 8. And 2 times 3 gives me a 6. So now I'm just going to combine them together because this is my matrix. A 1 by 3. Okay? So that's going to be a 2, 26 plus 10 is going to be 36. 4 minus 8 is going to be a minus 4 plus 2 is going to be a minus 2. And 2 plus 9 is 11 minus 8 is going to be a 3 plus 6 is a 9. That would be the final matrix. Okay? So let's go forward and keep working on these. This one says write the coefficient matrix expression to represent this quadrilateral with its vertices at. So what I'm going to do is I'm going to use x, y, and basically a 0 down here to represent my matrices. So my matrix is going to be located at negative 2, negative 5, 0. Negative 5, 6, 0. 7, 1, 0. And 10, negative 6, 0. That's the way I would represent that matrix. Okay? Now, this one says write a matrix expression scaling the triangle vertices and by a scale factor of 1/2. Well, I would write the matrix down. 8, 4, 0, 10, 12, 0, 15, negative 6, 0. My scale factor is 1/2, so it's a scalar multiplication. That means I multiply every one of them times 1/2, and I'll get 4, 2, 0, 5, 7.5, I'm sorry, 5, 6, I was looking at the 15, 0, 7.5, negative 3, 0. And my coordinates for the new location would be at 4, 2, at 5, 6, and at 7.5, negative 3. That's where I would write my new locations. Cool. So this one is asking me to translate something, translating 4 units left and 8 units up. So I'm going to write the vertex, the matrices again. Okay, it's going to be 3, -5, and 0, 4, 7, and 0, 9, 0, and 0. And when I'm translating, all I need to do is say 4 units left. That means I'm going to be adding a matrix to it. 4 units left. That means plus 4. Right? Because I'm going left 4 units. Minus 4. Minus 4. Minus 4. Minus 4. My x's are going to be minuses every time. My going up 8 units is going to be plus 8. And I would put zeros down here. And I add the two together, and I get a -1, 0, 5. I get a 3, 15, 8. I get a 0, 0, 0. That's where the new matrix would be located after doing the translation. And so my points are going to be at -1, 3, at 0, 15, and at 5, 8. Cool. Moving forward. Okay, this one is asking me to rotate something. If I'm going to rotate it, I'm going to be multiplying it. Okay? And I'm going to be multiplying it by a certain matrix. It's a certain matrix I'm going to be multiplying by. I'm going to use the matrix 0, 1, -1, 0, and 0, 0 there. Okay? And basically that's how I could rotate this matrix. So if I've got -8, 2, 0, there's 3 is here. Got 4 points here. So let's see here. 1, 2. I've got 3 points here. So this will work. Okay. -3, 1, 0, and 4, -5, 0. And I'm multiplying this. When I multiply down this column here, what I'll get as a result is 3. Because this times this gives me that 3. And then in the, let's see here. When I multiply this times that, I'm going to get a -8. And wait a second. 3, 3. Okay, hang on a second. I'm missing something here. Of course I am. Put it backwards. Okay, try again. Okay, let's see here. We would be multiplying it by 0, 1, -1, 0. And we're going to multiply the matrix -8, 2, yes, -3, 1, and 4, -5. Those are my 3 sets of points. So when I multiply this, I'm going to get a 2 and a negative, I'm going to get a +8 there. And then when I multiply this one by it, I'm going to get a 1 and a -3. And when I multiply that one, I'm going to get a -5 and a -4. And that would rotate it 90 degrees. Right? Well, wait a second. We're rotating it at 180 degrees. That changes this matrix here a little bit, doesn't it? That would change this matrix here to -1, 0, 0, -1. And when we multiply by that, we'd get a completely different answer here. Okay? We would get an 8, -2. We would get a 3, -1. And we would get a -4, 5. That would give us the new location. And again, these are x, y, x, y, x, y. Okay? And yes, I had to go look that matrix up because I can't ever remember it. The matrix to do the 180 degree rotation, -1, 0, 0, -1. And where did I find that? I went back to the course and I looked on the screen right here. 180 degree rotation. Okay? I'm not trying to fool you guys. Keeping those in your memory is hard to do. Okay. This is asking me to find the discriminant. Yeah. This minus that. 15 times 2, 30. Minus 6 times 3, 18. Will equal 12. That'd be my discriminant. That simple. Okay? Finding the discriminant of a 3 by 3. Much harder. I always hate doing this one. That's when I always come back to this. Okay? And I'm say, well, if it's going to be a 3 by 3, I'm going to enter that 3 by 3 into my calculator and just use the power of the calculator to calculate the discriminant for me. And you can see I'm just entering the values in 5, 2. Now that I've got all the values in here, I'm going to go second matrix. I'm going to go over to math, and I'm going to get the determinant of that matrix. And it's going to be matrix A. Oops, not that. It's second matrix A. Oops, it's not going to work for me. Okay, it's being mean to me today, guys. Calculator and I are having an argument. Second matrix A. Thank you. Now you do it right. And we press enter on that, we get a negative 278. Okay? Really is that simple to do. If I wanted to solve one of these by Cramer's rule, it's an easy process to do. First thing you do is you write down the matrix that is the coefficients. Negative 4, 3, 2, negative 1. Those are those. I've got my constants here, 2 and 4. And what I'm going to do is I'm going to replace the first row with this information. I'm going to first of all find the determinant of this one here. Negative 4 times negative 1, that's 4. 3 times 2, that's 6. 4 minus 6 is equal to a negative 2. Okay? Now I'm going to take this information, I'm going to replace the first column with my 2, 4. 2, 4, 2, negative 1. And I'm going to find the determinant of that. So that's 2 times negative 1, that's negative 2, minus 8. That's equal to a negative 10. So if I take negative 10 divided by negative 2, I'm going to get a 5. X equals 5. Let's do the same thing, only replacing the second column. So I've got negative 4 divided by 3. Negative 4, 3. I'm going to find the determinant of this. Negative 4, 3, and 2 and 4. I'm going to do negative 4 times 4. That's a negative 16 minus 6. That's going to be a negative 22 divided by a negative 2. It's going to give me 11. Y equals 11. Let's stick these in and just make certain they work. So negative 4 times 5 plus 2 times 11. Negative 4 times 5 is negative 20 plus 22 would be equal to 2. Let's stick it in here. 3 times 5 minus 11. 3 times 5 is 15 minus 11 is equal to 4. Check and check. We checked it out. There's my x, there's my y, and it's really that simple to do with Cramer's rule. 2 by 2 matrices, easy. 3 by 3 matrices, not so easy. Okay? This is where I'm going to write the matrix down. Okay? 1, negative 1, 2, 2, negative 3, 1, negative 1, 2, 3. Okay? I'm going to find the determinant of this, whatever that determinant is. Okay? I want to find its determinant. And then what I'm going to do is I'm going to replace this column here with the constants here. So I'll have negative 1, 3, negative 8, negative 1, negative 3, 2, 2, 1, 3. I'll find the determinant of this divided by this determinant from up here, and that will be the x value. If I put it in the second column, it would be a 1, 2, -1, -1, 3, -8, 2, 1, 3. I'll find the determinant of this divided by the determinant that I found of the original one, and that'll be my y value. I can do the same thing for the z values. It really is calculator-wise, key it in and do it. Okay? Inverses, on the other hand, difficult. What are we trying to get to? We're trying to get that when we multiply it times a value, what we'll get is 0, 1, 0, 1, or 1, 0, 1, 0. Okay? So we're trying to get that type of a matrix. If I'm trying to find the inverse of a 2 by 2 matrix, I'm going right back to where it says it in the lessons. And I'm trying to point out to you right here. See where it says the 1 over the determinant? So I'm going to find the determinant of the original matrix. And then I'm going to multiply that by, and I'm just swapping the positions and some of the signs on these equations. See how it's got A, B, C, D instead of being A, B, C, D? That's all you have to do to get this to work out. Okay? Let's see here. That would be like this one. If I wanted to do this one, I'm going to swap it around. It's going to be 2, 4, 8. I believe it is. Let's make certain. I always make certain I try to get this right, because this is the one that really confuses me a lot. Okay, so I've got D and negative B up here. Okay, that'd be this column on this one. So this column is going to be D and negative B. Okay, so this one is going to be the other column, and it's going to be negative and positive there. I believe that is correct. C and A. Yes, I believe that is correct. Okay? So I need to find the determinant of this as well. That's going to be 16 minus 8, which is going to be 8. So it's going to be 1 over 8 times that. And that'll be my inverse matrix. So 1/8 of 8 is 1. 1/8 times -4 is negative 1/2. 1/8 times -2 is negative 1/4. And 1/8 of 2 is 1/4. Okay? That's going to be the inverse matrix. So, if I take 2 times 1 1/2, I'm going to get 2 minus 1. Let's see here, 2, 2. That'd be 2, and that would be 1, negative 1. Okay? And then if I take 2 times this, I'm going to get negative 1/2 and 1/2 plus 1/2. Okay? And then if I take 4, 8, 4 times 1 is 4, and 8 times negative 1/2 is a negative 4, and 4, 8, that'd be a negative 1, and 8 times 1/4 is a 2, plus 2. Well, let's see here. 2 negative 1, that's equal to 1. Negative 1/2 plus 1/2, 0. 4 minus 4, 0. Negative 1 plus 2, 1. Yes, we got the identity matrix back when we multiplied it. So this is the inverse of that. Okay? So if this is A, this is A inverse. That's the way you find it. It really is just a matter of memorizing where you relocate things to and multiplying times 1 over the determinant. Okay? Now, to do this, what you can do is you can set this one up with matrices 3, 1, -4, -2 times x, y will be equal to 1, negative 8. That's what we're saying when we write this system of equations out like this. So you could take xy was going to be equal to 1 over negative 8, not 1 over, 1, 8 matrix times the inverse of 3, 1, negative 4, 2. Okay? That's the way you can write these things. Now, you could key these in the calculator and do them, or you could try to figure out the inverse of this matrix here to begin with. Either way, it all works out to be about the same thing. Let's go ahead and figure out the inverse of this one right here. So finding the determinant first, that's negative 6 minus 4. That's a negative 10 that we're going to get for the determinant. So it's going to be 1 over negative 10 times, okay, see if I can do this right this time. A and B, that's going to be a 3 down here and a negative 1 up here. It's going to be a negative 2 and a positive 4. I believe that is right, but let me just check it to verify it. It's A, B, C, D. That's here. A, B, C, D. Yes. I believe I've got it. Okay. So we've got this equation. This is the rearrangement. So I multiply times the negative 10. I'll have 0.2. I'll have a 0.1. I'll have a negative 0.4. And I'll have a negative 0.3. That's my inverse matrix right there. And I'm multiplying that times 1, 8. That's the matrix I'm going to be multiplying by. So when I multiply these down here, I'm going to get a 0.2 minus 8 times 4 is 3.2. Okay, and wait a second, multiplying wrong. These two down that. So I'm multiplying wrong, sorry. Got it written wrong as a matter of fact. This one goes on the other side, doesn't it? Because this is a 2 by 2, I can't multiply that down that way. It's got to be written on the other side here, times 1, 8. Because these two down that one give me, yeah, yes, that's the way I want to do it. Okay, times 1, 8 is what I'm trying to multiply by. So 0.2 times 1 is 0.2. 0.1 times 8 is 0.8. So plus 0.8. Negative 0.4 times 1 is a negative 0.4. Negative 0.3 times 8 is a 2.4, negative 2.4. So when I do that little math that I've got there, what I'm going to wind up with is 1 and then negative, I believe I wind up with a negative 2.8. And my x and y values are that, x, y. So x is a 1. So if I put a 1 in here, I'm going to get a 3 equals 1. Subtract the 3, I should get a 4 out here. What did I not do right? That's a 0.4, negative 0.4. Should that have been a positive? Oh, let's see here. It was a negative 4. Should it have been a positive in that location? Yes, it's the negative C and a positive D. So this one should have been negative, and this one up here should have been positive, right? Yes. Okay. It was a negative 2, so it stays a negative 2. So this one should have been written as a negative. Okay. So when I multiplied it by that, I would get a positive 0.4 there. So, okay, a long way of getting here. Okay, 0.4 times this, that'd be a positive 0.4 and a negative 2.4, so this is going to be a negative 2 is my answer there. Okay, try again. 3 plus negative 2 equals 1. Okay, got that. Negative 12 minus plus 4 will give you a negative 8. Check. So those are my values, 1 and negative 2. You see how when I did it, I went ahead and checked it to make certain I was getting the right values. X equals 1, Y equals 2. When I didn't, I had to go back and check my math. First place I went to was, did I rearrange these numbers correctly? And I hadn't. This one needed to be a negative number. So when I multiplied it times a negative number, this became positive. Positive. Okay? That's why I was getting some wrong numbers here. When I then multiply 0.4 and negative 2.4, yeah, this adds up to negative 2. Cool? Okay. What I have done by working these 18 problems, I've worked enough problems that'll be just like your multiple choice questions and just like your part 2 questions. Hopefully you've gotten enough information that you'll be able to go forward with this. If you have any questions, I'm not available during the day, but if you send me a K-mail, I will respond to your questions. Okay? I look forward to talking to you later. Bye.